and welcome back. We'll be looking at complex numbers again, and today we will be doing some subtraction. So it's basically like the addition, but with one little twist, and most books will show you how to take the number that is being subtracted, turn it into the opposite number, and then add it. It'll make more sense as we show it. It's standard to do it this way, although you don't have to. You could subtract the one real term from the other and the other imaginary term from the other. But we'll do it this way since most textbooks will show it this way. We'll be treating them again like before as vectors that will have an absolute length and a particular direction. We won't worry about the angles today, but we will be doing the parallelogram again. So here's our two numbers, U and V, color-coded. And so what we'll do is we will turn this one into an opposite, multiply in -1 to each position there. And then that will allow us to just add it to the opposite, okay, or adding the opposite. It makes it a little bit easier that way. All right, so let's get to it. We've multiplied in -1 to both, and then do you see here that the sign has been changed, okay? First this is negative, now it's positive, because we're adding the opposite of what we started with. And that's the same thing. The same thing is if you have 10, you can take away 5, or if you have 10, you can add a -5. You get the same thing. And that's kind of what we're doing here. So, all right, that being done, let's go ahead and put them together, and we'll make a parallelogram. And just like before, you can slide the red one up the U there and have it come out up here on top, or you can have the yellow one sliding down the red one, and you would get it here. Either way, you're going to end up with a result where the two of them add up together and you end up in a new place. So let's do that. And that's the little brown one here. That is our resultant vector. So when you add those two positions together, this is where you're going to end up. And basically we're done, but we're going to take it a little further like we did before, because I want you to get used to doing this. Treat it like a vector. Check out the absolute value. In other words, how long is it? So it's always good to know where it is, of course, and that these are the coordinates. You could see it as coordinates, a real component, an imaginary component. And then you can also find out what the length of it is. So let's do that then. I'll clean it up. All we have is the resultant complex number, and then just like before, we'll use Pythagoras. We have a height, we have a base of a triangle. We square the two and take the square root of it, and that gives us radical 17. And that is, we don't have to get a decimal approximation. There's no need to do that. Just keep it as radical 17. So really kind of a simple problem. Just like with addition, all you have to do is, when it's subtraction, add the opposite of what you had. Okay, so we would have a -3 there and a -I over there. Okay, it just makes it easier. So, all right, hope that helps. See you next time.